Hello and welcome to the section of the MATLAB tutor. Here we're going to continue working with calculus and we're going to learn how to calculate partial derivatives. It turns out it's really not too different than what we've done before, so let's just dive right into it. If we want to calculate a partial derivative, generally we're going to have a function of more than one variable. So in this case, let's say we're calculating or creating a function of x and y. So that means that I'm going to want a symbol variable x and a symbol variable y because both of these x's and y's are going to be the independent variables of my function f. So I'm going to create a function of f and I'm going to call it an inline function, right? That's creating a function for me. And then I'm just going to type it in just like I would. It would say, let's say I have sine of x plus y cubed, like this. All right. Now, when I define this function, I have actually two independent variables. So x is going to be an independent variable, and y is going to be an independent variable. So make sure you understand what's happening. Here's the function, and this last part's just telling it that x and y are the independent variables going into f. So when I hit enter, it writes it down just like you would have on a piece of paper. F of x and y, two independent variables, is equal to this. And just to kind of make sure you know, you can plug in values, x comma y into this guy and it'll calculate them appropriately. Now when you're taking a derivative, the function is the same, diff. So you would do f of x comma y, and you have to tell it what variable you're taking the derivative with respect to. All right, so if I'm taking the derivative with respect to x, then this is the answer I get. Now if I look at my original function up here, if I take my derivative with respect to x, then this y cubed is just a number. It's just a constant, so it drops away when I take the derivative. And the derivative of sine is cosine, so that's calculated correctly. If I pull up the last command and just replace this with a y, then I'm going to do the other guy. I'm going to pretend that x is constant, so it's going to drop off, and the derivative of y cubed is simply 3y squared. So in a large picture, in a big picture, that is how you handle multivariable functions in calculus. In fact, we could create a third symbol variable and call it z, right? So now we have three symbol variables, and I could create another function, h of, or I should say h is equal to inline, and I could just create anything I want. I could say, x to the 10th minus y squared plus log of z. And x, y, and z are the independent variables. So I've created a function of x, y, and z, and I'm telling the MATLAB that the independent variables are in fact x, y, and z. So my inline function is written just as it is there, right? And then I can take the derivative of h, x, y, z, and I have to pick a variable to take the derivative with respect to. If I pick x, MATLAB's going to hold everything else constant. So all this stuff here in this case would be constant. So the answer I get is 10x to the 9th. If I pull the command back up and I take the derivative with respect to y, then this is held as a constant, so it drops off. This is held as a constant, it drops off. And the answer I get for the derivative is negative 2y. And finally, if I calculate the derivative with respect to z, the partial derivative with respect to z, I'm going to get this, 1 over z, because all of this stuff is a constant and it drops away, and the derivative of a logarithm is just 1 over the variable. So partial derivatives really are handled exactly in the same way that regular derivatives are handled. There's no separate function for it. It's just that you have a multivariable function in here to begin with. All right, so now what I want to do is go and show you how to calculate a derivative of a function of more than one variable and evaluate that derivative at a point. So what we're going to have is, let's go ahead and calculate or create a new function. We'll call it h, and we'll say that it's equal to, let's make it a function of two variables to make it a little bit easier to handle. So we'll have x, let's say x cubed, let's just say y times x cubed. Let's do it like that. Actually, just to make it a little easier to read, we'll have x times y cubed. So that'll be our function. And of course, it's a function of x and a function of y. So we create the function, and that makes sense exactly the way it's written there. Now we want to calculate the derivative. Now we know we can pass this to the diff operator, the diff function, and get the value back. But we want to define a function so that when we get our answer, we can plug numbers into it, right? So let's go ahead and calculate. Let's calculate the derivative. And to do this, we'll have to set it equal to an inline function, which just tells MATLAB, create a function for me. What function am I creating? Well, you're calculating the derivative. You're calculating the derivative of h of x comma y, and you're calculating the derivative, let's say in this case, with respect to x. All right, whatever. You could just pick whatever you're trying to do, but let's just say we're taking our h of two variables, our function of two variables. We're calculating the partial derivative with respect to x. And we put a comma here because we have to, don't forget this is an inline function. It's creating a function. The final function we get is going to be a function of x and a function of y. So make sure you understand what we're doing. We're taking the derivative of this function with respect to x. That's the function we're creating inside this inline parentheses. The result of it is going to, in general, be a function of x and y. And we're setting this equal to the derivative label that we have. So we hit enter, and it creates our function, right? So in this case, it's y cubed. Because this is a fairly simple function, x times y cubed. When you take the derivative with respect to x, then you basically hold y constant, right? So you hold y constant, and this is the value that you're going to get. So you can take derivative 1 comma 1, and it'll calculate a value back. 1 comma 4, it'll calculate a value back. Now, if we go back up a little bit and change our original function to something a little more complicated, so instead of something like this, let's do it like this. We'll put parentheses on the top, and then we'll put a division bar, and we'll do x plus y. So this is a much more complicated function. So what we're doing now is we're redefining h to be x times y cubed on the top over x plus y on the bottom. So this is now a new function. You can see it right here. And we're going to go up a few other commands, and let's assign the label derivative to calculate the derivative, set it equal to a new function that we're calling derivative. We're again taking the derivative of our h function with respect to x, and our new function is going to in general be a function of x and y. So we hit enter, and here's our nice ugly looking derivative. We can fix that by taking derivative and basically sticking it in the pretty function, and we have to specify the arguments, x comma y. All right, and so here's our derivative, right? So y cubed over x plus y minus all this stuff. So basically what we're doing is we're taking the derivative with respect to x, we're sticking it in the inline argument to create a new function, which is always in general going to be a function of x and y. This is just like regular old calculus. When you take a function of two variables, you take a partial derivative, the function you get back is in general going to be still a function of two variables. And that's what we have here. And when you do it this way, you can take that derivative and put whatever you want in there, and it'll calculate a single value back. So you can plot this, you can perform additional calculations or functions on this new function that you've created, derivative. You can do whatever you want to it. So basically, go and define your inline functions, define your mathematical functions as a function of more than one variable. I've shown you how to do that. I've shown you how to take the partial derivative using the diff function, and I've showed you how to take the answer that you get and assign it to a new function so that you can plug in values. And so this is the kind of things you'll be doing constantly when you're really calculating things with MATLAB and programs. So make sure you understand how to do this, practice it yourself. Follow me on to the next section where we will continue learning how to use calculus in MATLAB.